All right. Welcome back, students. Welcome to Unit 17, Revising and Replication. I hope you had a great weekend, and let's go ahead and start our last week of class. So some of our objectives today is what we're going to do is talk about what replication is overall and review the different types of replication that happen in scientific research. Then we're going to go ahead and explain why replication is so important in the scientific research field. Lastly, we're going to explore what's been deemed as the replication crisis in psychology and all of scientific fields in general. This is an extremely important subject. It's been, for the past decade, the replication crisis has been a serious impact on our field. And so it's best that we discuss everything that's been going on with it so that we can avoid these replication crises that happen in the future. So the first thing that we're going to discuss in this lecture is study replicability. A study is replicable if it can reproduce the same results it had previously. And oftentimes, as scientific researchers, our goals in this is to have a replicable study. So where this starts a lot in your methods, right? Well, oftentimes, we want to be able to have methods within our scientific research papers that can be replicated overall. And if our methods are written well enough, then other researchers or even ourselves can replicate our studies. In theory, we should be able to replicate studies 95% of the time with the same results, assuming we set our alpha value at 0.05. So you know that p-value that you hear a lot about? That's all set up because of an alpha value that we set before. And what that's saying is that given the results that we saw, there's only a 5% chance that that is not the true result, given our null hypothesis that there is no true result. However, as we'll discuss later, oftentimes this isn't quite the case. In fact, we're only seeing about 36% of studies being replicated most oftentimes. So this means that scientific fields are oftentimes going through something known as a replication crisis, which we'll be talking about later in studies. And we'll discuss why this is happening and what causes a study not to replicate like it did before. And additionally, a lot of scientific researchers often find themselves offended by this replication crisis, but really it's just a part of the scientific process and in order for us to completely understand how this works. When we're doing replications, there's 3 different replications that we can take on. And your book does a really good job at explaining all these replications. In fact, better than I'm going to be doing in this lecture. So I would really encourage you to read your book to learn about what all these different types of replications are, and additionally see instances in which these replications have been used in the scientific literature. Our first type of replication is called direct replication. This is when a researcher repeats a study as closely as possible. This is completely methods-based. This is exactly why in our scientific research, when we write our scientific studies, it's so important to lay down your methods as clearly as possible for other researchers. That way, these other researchers are able to replicate our studies. Next is conceptual replication. This is when a researcher explores the same research question but uses different procedures in order to replicate the study. This is all based off of theory. In theory, a replication should hold up if the theory holds up. So therefore, they use the same exact theory that another researcher used in their research study and say, I will use the same theory but different methodological approach in order to reproduce the same results. So in theory, this theory should hold up essentially. And if it doesn't, then we have to question, is the theory good enough on its own? Lastly, we have our third type of replication, which is called replication plus extension. This is in which a researcher does a direct replication, so the first term that we heard of, a direct replication of a study, plus adds in a new element to the study. So essentially, this is where a researcher does the direct replication where they copy the methods as closely as possible, but they add some new condition. Oftentimes I find this is in experimental studies in which we add in a study condition so that we can assess the original replication plus add in some more research. This is probably my favorite type of replication because not only are we repeating old information, but we're understanding new information as we go on. This is both method and theory based because if we follow the methods, then it should replicate directly. And additionally, we should have this, if we have the similar theory, then the theory should hold up. If the theory doesn't hold up, then we need to go back and rework the theory in order to have an understanding of the replication and why it didn't work initially. This might seem relatively clear to you, but it actually hasn't been so clear to researchers in the past, in which we ask ourselves, why would we even replicate the study to start with? And really, this might sound like a stupid question, but it's not, because for many, many years, there was no scientific replication that happened for decades ago. It's only one of the more recent studies that we're starting to find that replication is exactly key to understanding our scientific results, especially when we know that just by chance you're going to find a significant effect 5% of the time, assuming we set our alpha value at 5%. So we need to make sure that all the studies that we've been running for this whole time don't run into that 5% range of effective studies that aren't really just significant by chance. Additionally, we replicate studies because it provides validity to the original study as well. If we are able to replicate the results, it makes our case even stronger that says, hey, guess what? Our study held up in this replication, therefore, it's likely that the results are more true. In an ideal world, we'd be replicating studies all the time, but it's a matter of A, there's sometimes not an interest by scientific journals to replicate studies. Additionally, it takes a lot of time and effort to completely replicate a study, and people are oftentimes interested in new ideas, which is why you don't see replication studies happen nearly as often, despite how important they are towards the progress of science. Now that we have a better understanding of replication in psychology and scientific research, we can discuss something now known as the replication crisis. The replication crisis was started by the Open Science Collaboration, otherwise known as OSC, in which they tried to do direct replications of 100 psychological studies. From these studies, only 39% of the studies were able to be properly replicated with similar results. This caused a lot of debate in the field, and a lot of people were very mad at this because many researchers took offense to their studies being replicated and oftentimes failing because of this. However, the Open Science Collaboration was just doing their job in trying to replicate these scientific studies with direct replication techniques while trying to replicate the methods that the psychological studies did. And with that, as we would expect with these 95% of studies being directly replicable, we only found that 39% of the studies were able to be properly replicated. So we have to discuss, why did this happen? Well, there's a lot of reasons that this happened, but we're only going to be discussing 3 of the main reasons that why it happened. The first reason is because these were low sample size studies, otherwise known as underpowered studies. The next is these studies oftentimes were a victim for hypothesizing after results are known, otherwise known as harking. And additionally, many of these studies were victim to p-hacking as well, which we'll discuss in the next slides. The first reason that we were unable to replicate as many studies as anticipated was because of the low sample sizes within the psychological studies. In a small sample, extreme cases oftentimes have a heavy influence on the results. Therefore, these extreme cases are able to produce significant results even though they're not truly representative of the true population. So this is especially important in psychology because many of the effect sizes we work with in psychology have smaller effect sizes, so we're required to have larger sample sizes to detect these small effect sizes. These are oftentimes known as underpowered studies. Another problem that occurred was something called hypothesizing after results are known, or in shorter terms, harking. In reality, it's vitally important that we do not change our hypotheses after we have seen the results of the study. In general, you should always hypothesize first, then obtain the results in order to see the outcomes that are associated with this. If you do it the opposite way around, this can result in data fabrication. We learned about data fabrication in one of our earlier lectures, in which case it's essentially where someone changes the results of a study based on the results that they found later. So what was going on is researchers were not honest in their methodologies, and they would indicate that this was their hypothesis all along. However, this is questionable research practices and would lead to varied results and stronger results than was anticipated. Another questionable research practice that has occurred in the past is known as p-hacking. P-hacking is essentially when researchers would run multiple analyses until the results fit their hypotheses. So for example, you still stop collecting data once your p-value reaches under the threshold of 0.05, or run multiple analyses but only report those that had the threshold of p less than 0.05. Essentially, p-hacking is very bad and is part of a big data fabrication technique. But if we have certain solutions to p-hacking, then we can avoid them happening in the scientific literature. Since the coming of the replication crisis, we've had many solutions that have come about. To start, the first solution would be to have larger sample sizes in all of our studies. This is indicative of more power in our studies, and that our ability to generalize our findings is much better. Next would be to practice open science techniques. This is where we make our data and analysis more transparent to anybody to view them so that they can make judgments for themselves on how well the analysis was run. And additionally, by making the data transparent, we can be sure that there's no data fabrication techniques utilized on this. Next, we encourage pre-registration of hypotheses. This encourages that so that people will not hypothesize after results are known, otherwise known as harking. By pre-registering hypotheses, we can be ensured that the results came after the hypothesis and that the results were not influenced in any way after they were known. Next, we want to always encourage more replications of studies. With more replication of studies, we can have more validity to those studies and be able to generalize their findings to a wider audience. Next is to be just aware of the problem. Awareness is half the battle. Therefore, by having awareness of the problem, we're able to overcome it by having these better techniques of larger sample sizes, practicing open science, and pre-registering our hypothesis, and encouraging replication of studies. By having this awareness overall, we'll have a better understanding of the solutions to be able to have a better scientific research. So in summary, there are three types of replication techniques. Additionally, replication is necessary and vital to be able to generalize scientific findings. The replication crisis exists, but we have effective solutions to overcome it. In fact, many of the fields have now been going about and having better solutions to the replication crisis. And additionally, things like the Open Science Consortium have come around to make sure that all science is open and that we can have better replication of studies, and in fact have direct replication of studies to ensure that the scientific process is ensured.